Okay, so now I'm going to talk to you about polynomial and rational inequalities. Before we can get into this topic, I need to talk to you about what a critical number is of a polynomial or rational expression. So let's talk about a critical number. A critical number is a number that makes the expression equal 0 or undefined. Now we're only going to deal with the undefined portion of this if you have a rational expression, because polynomials are actually defined for all real numbers. So let's say you had a polynomial that factored into 3x minus 5 and 2x plus 1. Well, to find the critical numbers, you would want to know when this polynomial equals 0. So you would set that polynomial equal to 0. And remember, the only way that it can be 0 is if 3x minus 5, the first factor, is 0, or 2x plus 1, the second factor, is 0. And notice here I went ahead and inserted the next step. For 3x minus 5 equals 0, that's true if 3x equals 5. And then if you divide both sides by 3, you get that x equals 5/3. So 5/3 would make this expression 0. For this factor, 2x plus 1 equals 0, that's equivalent to saying 2x equals -1, which would give you that x equals -1/2. So the critical numbers for this expression would be x equals 5/3 or x equals -1/2. Now, if you have a rational expression like 3x minus 1 over x minus 5, then basically what you're going to say is, when does this equal 0? That's where you're going to get one answer. And this equals 0, the only way this can be 0 is if the numerator is 0. So basically you're going to be solving the equation 3x minus 1 equals 0. And that's a pretty simple equation to solve. Just add 1 to both sides and you get 3x equals 1. And then divide both sides by 3 and you get x equals 1/3. So one critical number is 1/3. Okay, so x equals 1/3 is one critical number. But also, since this is a rational expression, we need to figure out what makes the denominator 0. And so we also have to solve the equation x minus 5 equals 0. So x equals 5 would be what makes it 0. So therefore x equals 5 makes the denominator 0, or since that makes the denominator 0, then it makes this expression undefined. So x equals 5 is also a critical number. Now when I say this, make sure you realize that by definition x equals 5 is a critical number, but also know that the domain of this expression does not include x equals 5. So just because 5 is a critical number, it doesn't mean that it's in the domain. So because remember, your domain, or you have to exclude values that make the denominator 0. So technically, by definition, these are both critical numbers, but one's a critical number because it makes the expression equal 0. The other's a critical number because it makes the expression undefined. Now let's take a look at this expression here, x squared minus 9 over x squared minus 1. Well, if you set x squared minus 9 equal to 0, then the only way this can equal 0 is if the numerator is 0. So we're going to solve x squared minus 9 equals 0. Now I didn't show you how I solved that, but you can solve it two ways. You can solve it by factoring. If you factor this into x plus 3, x minus 3, you'll get two answers, x equal plus 3 and x equal minus 3. You could also use the square root theorem, where you just said x squared equals 9. But if you solve it that way, you have to remember, when you apply the square root theorem, x is equal to plus or minus the square root of 9. So you would have x equals plus or minus the square root of 9. So that would also give you that x equals plus or minus 3. So either way, whether you solve it by factoring using the square root theorem, you're going to get plus or minus 3 are the numbers that make this fraction equals 0. So minus 3 and plus 3 are critical numbers. Then the other thing, and don't forget this, is again any numbers that make the denominator 0 would be a critical number, because that would mean those are numbers that make the expression undefined. So I would set x squared minus 1 equal to 0, and then the same way that I got x equal plus or minus 3 over here, I would get x equal plus or minus 1 here. So again, I could solve this by factoring into x plus 1, x minus 1, or I could just solve the equation x squared equals 1. And I won't go through that, but you know, you would go through this, apply the square root theorem just like I did over here, and you would get x equals plus or minus the square root of 1, which would give you minus 1 and plus 1 as the solutions. So all four of these numbers would be considered critical numbers in this expression. And now we'll move on to what do we actually need to do with those critical numbers in a polynomial or rational inequality. And first I'll do the polynomial inequalities, and then I'll hit the rational inequalities on the next video. Okay, so right here we have a polynomial on the left, and we have an inequality. So we want to find out, when is this polynomial less than 0? Now there's no shortcuts here. You have to do this. There's no like identifying steps that you can look at. You must identify the critical numbers. Now to identify the critical numbers, I'm going to write the polynomial. I'm going to set it equal to 0, and then I'll factor it. So I'll get the two factors, x plus 4, x minus 2 are the factors. And then I'll set each factor equal to 0, just like I did up there. And so when I get x equals negative 4, that's one critical number, and x equal 2 is the next critical number. Now, what I'm going to do is I'm going to identify from these critical numbers, this identifies three intervals. One interval is negative infinity to negative 4. The other interval is negative 4 to 2. And the other interval is 2 to infinity. So basically, the two critical numbers break up the x-axis, or the number line, into three regions. And so down here you can see I've drawn the number line. Right there's the number line. And I broke it at negative 4, and I broke it at 2. Notice the vertical line just shows you where I broke it. Because I know at negative 4 it equals 0, and at 2 it equals 0. So those are my critical numbers. And what I'm interested in is what's happening outside of these points. Like what's happening to the left of negative 4 in this interval. And what's happening between negative 4 and 2 in this interval. And what's happening to the right of 2 over here in this interval. Well, it turns out that whatever's happening with one number in this interval, negative infinity to negative 4, it must be happening with all numbers in this interval. So I only have to test one number in this interval to find out whether the expression is positive or negative, because that's what I'm interested in. If I want to know when this expression is less than 0, that just means I want to know when is it going to be negative. So I'm going to pick one number that's in this interval. Now I could pick negative 10, negative 100, or some weird number like negative 5.8, but I'm going to choose the number that's probably easiest to work with. So the number just to the left of negative 4 would be negative 5. And what I'm going to do is I'm going to put it back into this expression. But I'm actually going to put it not into the trinomial. I'm going to actually put it into the factored form. So I'm going to plug negative 5 into this form. So let me plug negative 5 into the first factor. Negative 5 plus 4 is negative 1. But I really don't care about the value, just the sign. So negative 5 plus 4 is actually, notice down below here I wrote, that gives me a negative. So I have negative 5 plus 4, which is a negative number, and then I have negative 5 minus 2, which is also a negative number. So I know that if I were to multiply those two factors together, I'd have a negative times a negative, which is positive. So I know that that interval is going to give me positive values. So all the values in this interval will yield positive values. Now let's try this interval. I need a number between -4 and 2. Well, since 0's in there, I'm going to just use 0. So plug 0 in up here at x plus 4. 0 plus 4 is positive, so that's positive. And then 0 minus 2 is negative, so that's a negative. And I know when I multiply those together, I'm going to get a negative. So that tells me that I'm going to get a negative if I plug any number in this interval into the expression. And then over here, I'm going to plug, I need a number greater than 2, so I'm just going to use 3. And so when I plug 3 into this, 3 plus 4 is positive, 3 minus 2 is positive, and a positive times a positive is a positive. So I know I'm going to get a positive. Now remember, I wanted to know when my expression was less than 0, which means when is it negative. Well, it's going to be negative only in this middle interval, -4 to 2. And it didn't say less than or equal to 0, it just says when is it less than 0. So my answer is from -4 to 2, but does not include -4 or 2. So that would be my solution of when that expression is less than 0. Would be the interval from -4 to +2. Okay, now that you understand the general concept, let me go ahead and speed this up a little bit. Here I want to know when is 2x squared minus x minus 3 greater than or equal to 0. So I want to find the critical numbers. So I'm going to set that equal to 0, then factor it. So it factors into 2x minus 3 and x plus 1. If I solve those, set them equal to 0 and solve, I get x equals 3 halves and x equals -1. Well, that means I'm going to break the number line up into 3 intervals. You always go to the smallest one first, -infinity to -1, then -1 to 3 halves, and then 3 halves to infinity. Okay, so now down here, I basically I draw a number line right here, and then I break that number line at those values, -1 and 3 halves. So I have -1 and 3 halves there, and then I'm going to look at what's happening in those intervals. Now to the left of -1, I'm going to choose -2. And if you plug -2 in this expression, again you're going to get a negative here, which is positive. If you plug 0 in, you're going to get a negative times a positive, which is negative. And then if you plug +2 in, which is a number in that interval, you're going to get a positive times a positive, which is positive. Now my objective here was to find out when is this greater than or equal to 0. So in other words, when is it positive and when is it equal to 0? Well, if you'll notice, it's positive in this interval and it's positive in this interval. So those are the two intervals that I use. And note the brackets, because I also want to include those numbers because those are the numbers where it equals 0. Remember, I wanted it greater than or equal to 0. So that's the solution for that one. Okay, I've got 2 more. I'm going to work this one, and then number 4 you can just pause the video and see how I solve that one. Okay, so this one, if I factor this by grouping, which I've done earlier, so I'm just going to drop down to where I factored it by grouping. I get x squared times x minus 3 minus 1 times x minus 3. Then factor the x minus 3 out, and it factors into x minus 1, x plus 1. Now, the 3 critical numbers I get from here are 3, 1, and -1. Now, if I take my number line and I break it at -1, +1, and 3, I get 4 intervals here listed: -infinity to -1, -1 to 1, 1 to 3, and 3 to infinity. So I pick -2, 0, 2, and 4 as my test intervals. And if I plug -2 into here, it's actually going to give me a negative value. If I plug 0 into here, I'm going to get a negative times a negative times a positive, so I'm going to get a positive value. And if I plug 2 in, I'm going to get a negative times a positive, which is going to give me a negative. And then if I plug 4 in, I'm going to get all positive, so I'm going to get a positive. And now, since I wanted when is it less than 0, I choose the 2 negative regions there, -infinity to -1 and 1 to 3. And So there's my solution, negative infinity to negative 1.